All right, so I'm just going to rewrite this. Log base 4 of 128. We chose a strategic change of base. We rewrote them as base 2, 2 to the power 7. Log base 2, 2 to the power 2 gives us 4. 7 halves, 3.5. Okay, questions, comments, concerns about this example? We're ready for the next rule? Okay. Here is a summary of everything we've done so far. Here is what we started with. The log of any base of 1 is 0. The log of any base, if the same number is inside the log, it is 1. If we have a log of any base with 2 numbers on the inside that are multiplying, we can separate them by adding them. If the inside is dividing, we can separate them by subtraction. If our inside has an exponent, we write it as a coefficient. If we have a base that is not working for us, we cannot simplify or calculate, we can choose a different base. If we have a calculator question, we're choosing base 10. If we have a simplification question, we're choosing a base that can cancel out. So now let us put some of this to work and do some real examples that are maybe a little bit more challenging. Using properties of logarithms, write each logarithm in terms of log 3 and log 5. So looking at example A, log 45, what can I write this as? What makes 45? So we can do 9 and 5, or you can do 15 and 3. Now I'm going to ask you, which one of these can we use to our advantage to simplify as much as possible? 9 and 5 would be better. So how would I write this? Log 5 plus almost. I could 2 log 3s, right? So you could write it as log 3, adding them, right? Or you can say, okay, 9 is 3 squared, so I've got 2 of them. Okay, what about B? Two log 5s, that's the top, minus log 3. Okay, so we've written both of them in bases, or sorry, using log 3s and log 5s, which is what the example asked of us. Okay, next, find the exact value. Exact means either fractions in lowest terms or reduced radicals, but no decimals. The exact value of this. How can I rewrite the inside? Seven 1/4, right? Because remember that fourth roots are the same as an exponent of a quarter, right? Roots are exponent fractions. So I can, because it's an exponent, it becomes my coefficient. So this is 1/4 times log 7 of 7. Well, that's very easy. This is just 1/4. Done. right? Because the base of the log matches the inside of the log. It's just a quarter. Okay, next one. So notice the base and the inside are the same, but they both have exponents. So how would I simplify this? I'm hearing a 6. That's right. Can we skip a step? 6 minus 2 is 4. Right? Because this is 6 log 5 of 5 minus 2 log 5 of 5. Log 5 of 5 is 1, so it ends up being just 6 minus 2. Oh, I made a mistake. Oh, Miss Gordon. Oh, Miss Gordon made a mistake. I'm like half right. I get part marks. What did I miss? Not quite. Not quite. I missed that this is not a single term. This is 2 terms with a minus sign. Oh, snap. Wait, no, I didn't. Oh my gosh. I heard whisperings, and usually when there's whispers in the corner, that means Miss Gordon did something wrong. Oh my gosh. Okay. Oh, I'm right, which means you are also right. Log 5 of 5 is 1. Exponents are the coefficients, so we just end up with 6 minus 2, which is 4. Oh. Okay, here's the long way to do it. I'm just going to show you the long way to do it. The long way to do this is this. This is log base 5 of 5 to the 6 over 5 to the 2, which is log base 5 of 5 to the 4, which is 4 log base 5 of 5. I still end up with a 4. Sometimes when I do the math in my head, I psych myself out that I'm skipping too many steps. You already started the next one? Okay, let me catch up. Am I doing what you're doing? You're copying what I'm doing, okay? Okay, what do I do next? What do I do next? Okay, I'm going to show you 2 ways to do this. 2 ways to do this. How could we write a quarter in base 2? 2 to the negative 2. So option 1. Oh, option 1. I could say log of 2 to the negative 2 of 2 to the 11. Can I write 2 to the 11 in a way where I have negative 2, like 2 to the power negative 2 to the power of something else, so that it reduces? Okay, good. I will say that again. I want to rewrite the highlighted part as 2 to the negative 2 to the power x. What could I put so that negative 2 times x gets me 11? Do you see what I'm trying to do? I'm trying to make an exponent to make it a coefficient so the log goes away. What could I put for x so that negative 2 times x gives me negative 11? You're on the right track. 5.5 or 11 over 2. So if x equals negative 11 over 2, then I'll get a negative 11 over 2 times log base 2 to the negative 2 of 2 to the negative 2, which just gives me negative 11 over 2. I found it. I'll show you another way that maybe it will make your brains maybe a little bit happier doing it the other way. But again, strategic writing of things. We're doing some mathemagic. Yeah. We're mathematicians, not just mathematicians. Okay, this is option 1. I will show you option 2. Option 2. You are going to write this as log base 1 over 2 squared, or you can write it as 2 to the negative 2. The first step is the same, of 2 to the 11. And you're going to make it equal x. One over 2 squared. Okay. Leave it as a 4. Okay, look here. I'm just rewriting this. Okay. So I'm showing you how you could do it another way. Make it equal x and solve for x by rewriting it as a exponential rather than a log. So if I rewrite this as an exponential, this is 2 to the 11 equals 1 over 4 to the x, or 2 to the 11 equals 4 to the negative x, or 2 to the 11 equals 4, not 4, 2 to the negative 2x. And then this becomes lesson 1 review. If you have the same base and the two numbers are equal, then the exponents must also be equal. And you'll end up with the same answer. So all of this is about trickery, smoke and mirrors. Okay? As long as you're doing sensible steps, right? You want to make sure that you're trying to get things into the same base as much as possible. So you can either do it this way or that way, whichever way is fine with me. Just show your work. Let's do a couple more examples. Flip to the next page. Okay. Very carefully, I want you to expand each expression. Let's focus on A. Expand using the rules we have. Well, what can you look at? What do you know? What can we do? We can start easy. I see a big divide sign, so let's do the divide part. Log base 3 of 3x to the 4 minus log base 3 of y squared. What else can I do? Keep expanding. One plus, keep going. Because I'm using the product rule here. Log base 3 of 3 plus log base 3 of 6 to the 4. But how can I rewrite 6 to the 4? Put the 4 in the front, whoop, and then leave the base 3 of x minus minus 2 log base 3 of y. Done. Inside each of the logs is a single term or variable. I cannot expand it anymore. All right, so the exponents became coefficients. The products became a sum. Actually, I guess I should do it in blue because I highlighted it in blue. And the quotient became a minus. All right, do it again. Do it again, do it again. Log of 2x minus 5 minus log 3. I'm missing something. Where's the 1/2? I could do it here or as a coefficient. Okay, can I break this up? Can I break the inside of the first term up? Why don't you think so? It is one term. And I can only split up things that are products and quotients. This is a difference. This is not a quotient. I cannot break this up. I'm telling you this and you're all nodding until your quiz or test comes along and all of you will make this mistake. Do not break apart a term that has a minus sign in it. That is as far as that thing goes, okay? All right, we've done expanding. Let's do simplifying. Condense the following in as few terms as possible. Almost a square root. Cube root, yeah. So this is log of cube root x times x minus 1 squared. Right? Your coefficients become the exponents and your pluses become a product or multiplication. So that is as condensed as this one can get. Oops. There we go. Okay, let's do B. Following the same process, log base 3, you tell me. X plus 4 squared over x. Lovely. Okay. Uno más. What else can we do here? Where is x squared? This is going to be a big one. So tell me, where am I writing stuff? Inside the bracket, numerator, denominator on its own. It's a numerator. Okay, so I have an x squared in the numerator. It's 5x squared. These are plussing, so that means that when we put them in the same log, they are multiplying over x squared plus 5 cubed. Wonderful. Okay. You're good? Flip the page. I don't know. Check the calendar. Yes, next Tuesday. Okay, change of base. On your calculators, it can only do two kinds of logs. A log base 10, which we've already discussed. And as we go on, I don't think we're going to do lawns in this unit, but if you do calculus next year, we'll talk lots about lawns. Oh yeah, we are doing lawns later on. Lawns. It sounds like a lawn. Like a lawn thing. No, it's not a lawn. A lawn is a special case of a logarithm where the base is the natural number e. You don't have to worry about it right now, but just know that a lawn is a log with a special base. That's all you need to know. Okay, our calculators only know how to do these two, so whenever we have, guys, you're making a long lesson even longer. Just chill. Hands to yourself. Okay. Are we ready? Yes. I know. It's sunny. Half the school's not here. You want to just get your driver's license and drive away. And you're almost there. But I need to finish this page. And then you can be done. Okay. Because our calculators don't know how to do change of base, you have to know how to do change of base. When we do a calculator question, the change of base will always be a base 10. The inside of the log is always the numerator. The base of the log is always the denominator. So as long as you can keep those guys straight, you will be good to go. So you're going to put this in your calculator as a fraction. Now, you have to make sure that when you do this on your calculator, you need to use brackets. Log bracket, blah, 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 close the bracket, over log bracket, blah, 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 close the bracket. Calculators and computers are not very good at understanding the notation unless you put brackets so that you can identify where it starts and where it begins. Some calculators and computers are smarter than others, but you don't know how smart or dumb your device is until it's too late. So be cautious, be smart, and do it this way. Okay, 6 more rules. However, I'm just going to state them. Okay, zooming in here. Log to the power, a base to the power of a log that has the same base essentially cancels itself out. So whatever is on the inside of the log, that's the answer. Because remember that exponentials and logarithms are inverses. This is essentially the same thing as saying b over b. That's a 1. It cancels itself out. Okay, or the inverse cosine of a cosine. You're just going to be left with whatever the angle is in there, right? Inverses cancel each other out. So when you have an exponential and a log and the base is the same, I cannot stress this enough. The base must be the same, then the inside of the log is what is left over. Then we take a look at the rule with negative exponents. If you have log base b of 1 over something, that is the same as saying log base b of x to the negative 1. We can just rewrite it and chuck the negative on the outside and get rid of the fraction. Okay. Similarly, if you have a log base b with an inside of a, if you did the reciprocal of that, reciprocal means put it under a 1, the base then goes on the inside and the A is now the base of the log. So again, these rules are to help you strategically simplify things without doing a lot of work. Okay. Following the change of base rule, if you have log in the numerator and denominator with the same base, and you want to change that base, those fractions are still going to be equivalent. Okay, and can I do an example? Hold on, let me just think. Here's an example of how this works. Is this true? Is it true? That's not true. Hold on. This is the exponential version of this. Hold on, hold on. I did it backwards. I did an exponential instead of a logarithm. Okay, let's do it in log-based form. Hold on, the inside must be the same. Let me change this to perfect squares, otherwise it'll be hard. Okay, here's an example of this rule. The only thing I've changed is the base of the logs. Can we simplify this? This is log base 2 of 2 to the 4. Log base 2 of 2 to the 2. Log base 4 of 4 to the 2. Log, well, I could just tell you that's a 1, right? So this becomes a 2. And then I have 4 over 2. This becomes a 2. There we go. The first example didn't work because I was showing it with exponents, not logarithms. It should have been logarithms. Okay, so if the inside of the log is the same and you want to change the base, you can, as long as you maintain all other things. And the base and top and bottom has to match. Okay, other last two rules here. Again, thinking of exponent rules. If you change the base to the reciprocal, it is the same as adding a minus sign to the outside. Right? And any two numbers, if the log base is the same, then they are equal, then x and y must be equal. And this follows from this rule. If b to the x equals b to the y, then x equals y. If the bases are the same, the exponents are the same. If the bases are the same, the logs are the same. Okay? Let's do some examples. Last couple. Two left, I think. Yeah, just two. Okay, looking at the new rules that you have here. How could I rewrite this? Log of 10(2), yeah, plus log of 10(5). What else can I do? Log 10(10), which equals 1. Beautiful. Okay. Two logs with the same base that are adding can combine as a product. Okay, last one. Use some creative thinking. What can we do? Can't see? Can you see now? Okay. Who said no still? You're okay? All right. So I did a slight change of base. What else can I do? I want you to do change of base. Change of base. Okay, I'm losing your guys' focus, so I'm just going to do it, okay? Okay, I see that both of these are not the same base, so I'm going to change the base, gentlemen, and make it base 3 because I know that they have a factor of 3 in common. So this is going to be 6 log x over 3 of 9, base 3, minus 12 log base 3 of x over log base 3 of 27. Okay, so I'm using the change of base rule that's at the top of this page. Okay. I chose a strategic change of base because I can see that 9 and 27 are multiples of 3. Okay, so that's my step 1. The next thing I'm going to do is I'm going to rewrite now 9 and 27 as multiples of 3. So this is going to be 6 times log base 3 of x over 2 log base 3 of 3 minus 12 log base 3 of x over 3 log base 3 of 3. Right? Because this is 3 squared and this is 3 cubed. So I'm changing the way that I'm writing the 3 and the 9. 3 squared, the square becomes the coefficient. 3 cubed, the cube becomes the coefficient. Now, if you'll notice, they already have a coefficient in the numerator. And I have a log base 3 of 3. The purple is going to go away. The blue and the yellow are going to simplify. So this is going to become 3 log base 3 of x minus 4 log base 3 of x. And I can collect like terms. This is a log base 3x. This is a log base 3x. 3 minus 4. This is going to give me a negative 1 log base 3 of x. Or if you want to write it as a positive, you can write it as log base 3 of 1 over x. Because coefficients are exponents. So if I wanted to make it positive, I could write it as a fraction, but either way is fine. Okay, so this uses quite a few of the rules that we've talked about. Today, you are going to practice this mathemagic, okay? And you're going to use all of these rules in order to simplify things. The bottom of your page has very, very common student mistakes. Do not be that guy. Do not be that girl. Do not be that person, because those people are not clever. You are clever. Okay, 3 common mistakes to avoid. If you see a plus sign inside of the log, that does not mean you can split it. That only works on products. Same with a divide, does not equal a minus. Wait, this one does equal a minus. Oh, no, it doesn't. This is log A over B, not log A over log B. This is correct. This is incorrect. This is incorrect. This is correct. Okay, if your entire log is squared, that does not become the coefficient. The coefficient can become, sorry, the exponent can become a coefficient if it is inside the log, not on the outside of the log. So this is correct. This is not correct. This is why brackets are important here. Okay. All right, let's take a look at your homework today. Flip your page.